Now we'll try to establish the relation between bulk modulus, Young's modulus and Poisson's ratio. That is the relation between K, Y and sigma. Now let us consider a unit cube, that is the length, breadth and the height, okay, which is equal to 1, a unit cube, and let Tx, Ty, Tz they be the outward stress along xyz direction. This is Tx, Ty, Tz, these are the outward stress in the respective direction. Let alpha be the elongation per unit length per unit stress along the direction of the force. It means along the direction in which we apply the elongation per unit length. Okay. Similarly, the beta, it is the contraction per unit length per unit stress in a direction perpendicular to the applied respective forces. Now let an outward stress Tx, it produces an increase in the length of alpha Tx in the x direction. So Tx along the x direction, it produces an alpha Tx, an increase in alpha Tx in x direction. So as it increases along the x direction, we observe there is a contraction in other two directions, that is, and Ty, Tz produces contraction, that is beta Ty and beta Tz in x direction only. Therefore, the length which was unity along the x direction, now it becomes, now that is the change. What is the new dimension, the length? It is 1 was there unity, that is 1 plus alpha Tx, that is increase, and minus beta Ty and minus beta Tz, it is the contraction. So this is the new length which is along the x direction. Similarly, for the y and z direction, if we give the same treatment, we get 1 plus alpha Ty minus beta Tx minus beta Tz, this is along y direction, and along z direction it is 1 plus alpha Tz minus beta Tx minus beta Ty. Therefore, the new volume of the cube will be, the cube was the unit dimension, now the volume, the new volume will be the product of all the three. Okay, so those product we have taken. Since whenever the outward stress is applied, the elongation or the contraction is very small. Therefore, alpha and beta they are small. Therefore, their power and their product is neglected during this multiplication. Their power and their product is neglected for the simplicity. Therefore, the new volume will be, it will be 1 plus alpha into Tx plus Ty plus Tz minus 2 beta into bracket Tx plus Ty plus Tz. Now let the Tx is equal to Ty plus Tz is equal to T. As we observe, the products, the powers of the respective powers and their product is neglected. So we get this equation, and let Tx is equal to Ty, that is equal to Tz is equal to the T, the applied, the stress. Therefore, it reduces to 3T. Okay. Next, since the cube we have considered the unit volume. So, increase in the volume. So, how much there is the increase in the volume? So, this minus the original volume was 1. Therefore, 1 plus 3T into alpha minus 2 beta minus 1. So, if we simplify, we get 3t into bracket alpha minus 2 beta. Next, instead of the outward stress, if we apply a pressure to decrease the volume, if the pressure is applied in a inward direction, the stress was outward direction. Now if you apply the pressure in the inward direction in all the for all the faces, then its new volume will be, okay, it will be 3p into alpha minus 2 beta. Instead of the T, the stress, outward stress, it will be replaced by a pressure. Therefore, the volume strain is given by change in volume by original volume. So the change in volume is 3p, this one, that is 3p into alpha minus 2 beta divided by the original volume is 1. Now the definition of the bulk modulus K is given by pressure divided by volume strain. That is, pressure is P, volume strain is 3p into alpha minus 2 beta. Rearranging, okay, simplifying, we get 1 by 3 into alpha minus 2 beta. Now this K is equal to 1 by 3 alpha. If you take out outside, it will be 3 alpha into bracket 1 minus 2 beta by alpha. So the alpha is taken to the numerator, that is 1 by alpha divided by 3 into 1 minus 2 beta by alpha. So in the previous derivation we have seen the Young's modulus Y is equal to 1 by alpha and sigma is equal to beta by alpha. So substituting these Y and sigma in this equation, K is equal to Y divided by 3 into 1 minus 2 sigma, or simplifying we get Y is equal to 3K into bracket 1 minus 2 sigma. Now we would like to establish the relation between Kn and Y. So the previous two equations, we know that Y is equal to 2n into bracket 1 plus sigma. We call it as equation number A. Just now what we proved, Y is equal to 3k into 1 minus 2 sigma, that is nothing but equation number B. So this equation A may be written as Y by n is equal to 2 plus 2 sigma. We call it as equation C. Similarly, the equation B, it may be written as Y by 3k is equal to 1 minus 2 sigma. We call it as equation number D. Now adding the equation C and D, that is Y by n plus Y by 3k is equal to, then RHS we add. So this may be simplified as the whole altogether. We can write it as 3ky plus yn divided by 3kn is equal to, so this will be equal to 3, or y is equal to y into 3k plus n by 3kn is equal to 3, or rearranging the term we get y is equal to 9kn divided by 3k plus n. Next, one more relation, that is the relation between kn and sigma. Now adding A and B, so these two equations now we are going to add. Adding A and B, we get 2n, okay, 2n plus 2 sigma is equal to 3k minus 6k sigma, or 2n sigma plus 6k sigma is equal to 3k minus 2n, rearranging the term. Or sigma, if you take out common, that is 2n plus 6k is equal to 3k minus 2n, or sigma is equal to 3k minus 2n divided by 2n plus 6k. So these are the two relations which I have established. Now the limiting value of the sigma from A and B, that is from A and B, the RHS these two we are going to equate. That is 2n into bracket 1 plus sigma is equal to 3k into 1 minus 2 sigma. Now the value of the sigma is going to be positive. We consider that is positive value are written. The value of this in this equation, the value of the sigma is positive when the RHS is positive. When RHS is positive, the sigma value will be positive. If sigma not more than half, 1 by 2 or 0.5, otherwise this RHS will be negative. Therefore, to be sigma to be positive, it has to be less than 0.5. This is one condition. Second one, for the negative, when sigma will be negative, that is we take the LHS. In the LHS, if it is less than -1, if it is less than -1, otherwise it will be negative. This will be negative. Therefore, we can consider the value of the sigma. It lies between -1 and half, that is 0.5. So it lies between these two, the limiting value, the sigma to be positive or negative, it lies between -1 and 0.5. But the negative value of sigma means elongation of the body accompanied by a lateral expansion, which is not observed in practice. This is nothing but we take a wire, a metal wire, and if we apply the load, then what happens? We can observe there is an elongation. So elongation will be there, but its thickness is going to decrease. When there is elongation, its thickness decreases. But here we observe that lateral expansion. We cannot observe the thickness to increase when load is applied. Therefore, this is practically not possible. Therefore, we take the value of the sigma values. It lies between 0 and 0.5 only.